Hello class, this is Mr. Coys. This is the free response question number 9 in your practice packet. So first off, as anything, read the problem, approach it, figure out what you need to do. So we have a frictionless block of ice with mass m slides down the ramp from rest, and then a thin hoop mass m and radius r rolls down the ramp without slipping. You will want to notice in the diagrams that these are obviously the same height and the same distance and the same mass. Alright, 1. So a student in a physics class placed 2 objects on top of the ramp as shown in the diagrams above. The ramp has a small rise at the end which causes the objects to be launched upwards at a small angle. First, the students placed a block of ice, which has no friction with the ramp surface, at the top of the ramp and released it. Next, the students placed a thin hoop at the top of the ramp and released it. Which of the 2 objects, if either, reaches a greater height after leaving the ramp? Justify your answer qualitatively without any equations. So on this one they do mean without any equations, which you can kind of figure out by looking at this down here, because B asks you to now justify your answer about which object reaches a greater height using appropriate equations, and C, it's explaining how B re-expresses A. So connecting all of your qualitative reasoning, your explanation, to your equations. So there are a couple ways you can solve it. By far the easiest is energy. You can always try to look at it through energy. And since we have a rotating object, we know that it will gain rotational energy. So for A, the first thing you want to think about is they start with the same energy. And while this seems ridiculously obvious, you need to state it. So point number 1, this is out of 3. So point number 1, it'll show up as well as I liked. Point number 1 is for indicating that in both cases, that the energy, and specifically the potential energy that you start with, is the same and it's conserved. So you have to indicate both that the energy is conserved and that they start with the same energy. As well, you have to show that you understand that the same amount of potential energy gets converted into kinetic energy for both. So they have the same potential kinetic drop because they both drop the same amount of distance. So that's 1 point. Alright, next, you need to indicate that although both of them have a lot of their potential turned into kinetic, and I'm writing with variables to save room, you would say this in words, that your potential goes to kinetic, but with the rolling object, some of it's not turned into translational, it's turned into rotational. So it doesn't have as high of max velocity. So it has a lower max because of this. And that is for your rolling object. And then finally, after you get all of those two things, you have to connect that, well, the one with the largest velocity, and specifically the largest velocity in the y direction, because if you say in the x direction, nah, because the x direction is not going to make it go up. It's specifically asking about height. So you need to specify the largest v is going to get you the largest vy, the largest vy is going to get you the greatest height. Alright, the more velocity you start with, the higher you can go, because acceleration would be constant for either of them. And then therefore, and you could have stated this anywhere, therefore, the ice is the height of your ice is going to be greater than the height of your hoop or your roller. So there's the 3 points for that. Alright, next for 3 points as well is now justifying your answer using equations. So hopefully it's relatively obvious, some of the equations from what we said before, what we're going to use. So you would need a conservation of energy for each one, so I'll have my equations for my ice here, and then it's easier to write hoop. So you need to have a conservation of energy that clearly shows that energy is conserved in both cases. So we have that our potential energy is equal to our, in this one, kinetic energy. Notice I can say that because I say my height ends there. So if I want to do MGH, that's my MGH. Which makes it a lot nicer to look at. Then for the hoop, it's again really similar because they have the exact same drop, but we have KT and we have rotational. Remember, it's just like 1/2 mv squared for the rotational, except m gets replaced by inertia, and velocity gets replaced by angular velocity, or wombo, or omega if you want to be formal. So hopefully, again, you can see here that all of our potential energy gets split between these two types of kinetic. So that's the first step. And therefore worth 1 point. Then you need some calculations showing that you can solve for what your velocity is, because ultimately your launch velocity is what's going to help you here. So you need to show that you can figure out what your launch velocity is, and that you don't have to solve for this one exactly. I mean, you should. But, here, let me pause and do the algebra on that. So on this one, it's fine if you didn't necessarily do all the algebra, as long as your equations show that you clearly could, given time, because this is a time thing. Preferably, you would come out with these. So we can just see with this extra subtraction term in here, the velocity it's going to have to be lower, is really just all this is proving. Hopefully it's, again, obvious, but show them that you know it's obvious. And then for these, the idea that you know that your Vy is equal to only a component of the original velocity. So if you are getting shot off at some small angle that we don't know, we know that our y here, since it's the opposite, is just sine theta of whatever you got before. So we know it's sine theta of your initial velocity. So that way you can show, okay, well, still, your velocity on the hoop is much lower. So that's 1 point. It was kind of the clunkiest stage. And then, last but not least, directly connecting it to the final height reached. So we got our velocity in the y direction. You could do one of two ways. You could go back and figure out essentially your kinetic energy in the y direction, but it's kind of, it would technically work, but you really shouldn't, because remember, we talked about energies being non-directional. If I give my energy in the y direction, it's not really right. You can kind of make it work, but you should use kinematics in this case. So we know that v squared is equal to v naught squared plus 2a delta x. So we don't know anything about time, so it's better to use the equation without time. We know that at the top, this is 0, and then you can just solve for x. And then Technically, if you want, you can put in that this is a negative g, and then that cancels out your negative, but it's not terribly important. It's better, but you should still be getting your points for that. And you've already showed that if I have a smaller v, I have a smaller vy, and therefore, and you should specify this is in the y direction. Acceleration in the y direction, or use g, that's an obvious acceleration in the y direction. And that is where you get your third point. And last but not least, if you've been point counting, you know this is only worth 1 point. And this is just put very vaguely as linking, essentially exactly what it asked for, which is linking your reasoning to your equations. So I'm not going to write all these, so just please listen, and this is where the proctors do have a little bit of judgment calls to make. So it gives you a lot of examples. So the large one, which should be probably the easier one if you got this far, is the equation mgh equals 1/2 mv squared, i.e. for your original, shows that the potential energy lost in sliding down the ramp is converted to translational energy of the block, while the equation mgh equals 1/2 mv squared plus 1/2 I omega squared, or Wampo squared, shows that only some of the potential energy lost in the sliding down the ramp is converted to translational kinetic energy for the hoop. So this is pretty much just like your final reasoning. So like the last explanation, you showed this to everyone, and then you're like, well, because of all of this, it works. So it's just connecting everything you talked about to the equation. Or again, substituting that final velocity in the y direction is 0, and that your acceleration in the y direction is g, gives you the equation v squared, or vy squared, equals v initial y squared plus 2ay delta x, and then gives this result, shows that the block will reach a greater height since it has a higher initial velocity. So just connecting all those equations you wrote to something you said in the reasoning gives you that final point. Alright, hopefully this is helpful. Again, please write any further questions you have, and again, feel free to send me questions on Remind.